Hello and welcome to my channel on Intimate Algorithms. So today in this tutorial we'll be looking at how to delete a node in double linked list. But before that we'll be learning about the structure of node in double linked list. So this is our node and we can see that it has the three fields. It has the three boxes. It means it has three fields. The middle one, this is called the info link, or you can say this is called the data field, and this one's right here is the pointer field. And since this field it point to the left side, a left node, it is called left pointer, or simply you can call it left. And this one is the right pointer, which points to the right node. And if we want to add any data into this node, then we can simply access this data field. And for example, if I want to uh, write 40 as my data, then this 40 goes inside the data field. And this node right here, we have the structure, and I will give its name simply node. And then I have the integer field right here, which is the data field. So int data, and I have another two field, that is the pointer field, and this pointer right here points to the another node. So it is struct node type and pointer. And then let me write its name as right, since it point to the right node. And similarly we have the left pointer here, so its name, it is struct node type and its name is left. So this is my structure of node. It has three fields: the data field and the right pointer and left pointer. So now we'll be looking at how to delete a node in double linked list. And here, in order to delete any node, we first need to ask the user about the location of the node they want to delete. For example, uh, say the location of this node is 2. So if we ask the user about the location of the node they want to delete, and say they give the location 2, and this 2 is integer type, then what we need to do is we have to point this right over here, and the arrow goes right over here, and we just have to free this node so that we have only two nodes in our linked list. So after deleting, we simply have these two nodes, and the left and the right pointer of our first node has the location 6000, which is the location of our second node, and the left pointer of our second node has the location 2000, which is the location of our first node. And in this way we can delete a node from our double linked list. So this location is the important variable we need to declare while deleting a node in double linked list. But in case if the user give the location, for example say 4 in this case, but we have the length of only 3, as we have 3 nodes, then in this case we have the location value which is 4, and this is greater than the length of our linked list. So in this case we have to give the error message for the end user, telling that the location is invalid, as there is no such location in the linked list. So this case might arise in our program. And if the user gives the location of 1, and if we want to delete this first node, then what we have to do is we have to point this root to our second node, and we just have to insert here null, and we can simply free this node, and right over here in place of 2000 we should write null. So after deletion of our first node, we have the root value equal to 4000, and right over here we have null. So in this way we can delete our first node if the user gives the location value equal to 1. So let's look at the program here to delete the node in double linked list. So first we have void. Let me give the function name delete, and let me declare a integer variable, say location, and length, and one other variable, say I. Also let me declare struct node and then pointer variable p and q, and in place of length I'll give the value returned by my length function. Sorry, let me write here len simply. Now in this case, this length function returned the value 3, since our double linked list has 3 nodes, and we can say length 3. So in place of len variable we have 3. Now let us ask the user for the location of node they want to delete, and let me collect that information in my location variable. Say that in location variable the user gives the input 4, then in this case location is greater than our length. As we know, 4 is greater than 3, so for this case we can simply give an error message to the user saying that this location doesn't exist. So we can write here if location is greater than the length, we can simply give an error message for the user telling him or her that no such location found. Else, if the location given by the user is equal to 1, then we should consider a case. So here the user want to delete this particular node right here. So if we want to delete this node, then this root should point to our second node, and in place of 2000 here we have to write 4000, which is the location of our second node, and in place of this 4000 right here we have to enter null so that we can free this particular node and it doesn't occupy any space, so that we can manage the space in our program. So here comes the use of this pointer. I'll use this pointer p first, and in place of p I will give the value of a root which is equal to 2000, so that p will also be pointing to this first node as it has the value 2000. So since p is 2000, we have p to write value. So p to write is 4000, the right pointer field is 4000, so p to write is 4000, and this value we have to store in a root. So inside root we have to give the value p to write so that the root right here will be pointing to our second node. And also in place of this 4000 of our first node, we have to put a null so that we can free our first node. So this 4000 is p2 write. So in p2 write, we're just inserting the value null. And also what we know is, since our second node becomes our first node, so in place of this left field of our second node, we have to place the null value since this has become our first node. So this 2000 is p2 write is simply 4000, p2 write is 4000, and 4000 to left is 2000. So p2 write to left, we have to insert the value null. So this is what we have done till now. In place of root, we have placed the value p2 write. So p2 write was 4000. So in place of root, we have placed 4000. And in p2 write, so p is 2000. So p2 write is this one. So in this place, we have inserted null. And p2 write to left. So in this place right here, also we have inserted null. Now we can see that this node right here is not connected to any other node, so we can simply free this node. So freeing this node means we have to free p, since p was pointing to this node, so in this way we can delete our first node. So let's write the logic for else if the location entered by user is 1. So what we have to do is simply we have to write this algorithm over there. So this is the algorithm what we have to follow when the user gives us the location 1. I've already explained to you about these steps, about this algorithm. Now let's look for the logic when the user gives the input other than 1. Now let's see what happens when the user gives the location 2 instead of 1. So the user wants to delete this node right here. It has the position 2. So to delete this node, the first node should point to the third node, and the third node should point to the first node, and in place of these two pointer field we have to insert null, so that finally we can free this node right here, and we can simply delete this second node by following this procedure. So let's try to create a logic here. In order to delete this second node, we have to pass the control up to our first node. For that, we have to point our first node with the help of our pointer p, and our second pointer q have to point to the node we want to delete. So q points to our second node. So to point to the second node, q should have the value 4000. So how can we give q the value 4000? So in place of q, we can give the value p2 write. We can see here p2 write, this is p, and p2 write field is 4000. So 4000 we can give it to q in this way, so that q points to the node we want to delete, that is our second node. But first we have to give the value p 2000. So how can we keep p 2000? Since we know that 2000 is the value of root, so in place of p we can simply write root, so that p also has the value of root, in this case 2000. Now comes the use of this integer variable I, so that we can pass the control up to our first node. So if we want to delete this third node, then we should pass the control to our second node, just one node before the node we want to delete. So for that we need the help of our integer variable I. So while I is less than location minus 1, what we do is we have to put the value p to right in our variable p so that we can traverse this node. So let's see what is happening. We have the value I equals to 1 in this case, and location minus 1, we have the location value equal to 2, so 2 minus 1 is simply 1. So 1 is less than 1, this condition is false, so we don't have to traverse in this case. Simply we have the value p equals to root for this case. That means p is already pointing to the node right before the node we want to delete, so we don't have to traverse in this case. Simply p has the value of root, which is 2000. So after this we have to write the logic q. So the pointer q have the value p to right, so in place of q we have to give the value p to right, so that q points to the node we want to delete, in this case 4000. So now q is pointing to the node we want to delete, that is our second node, which has the location 4000. Now we have to make the connection. Our first node should point to third node and the third node should point to first node. So for this, so in place of this 4000 right here, we have to insert 2000 so that the third node will point to our first node, and in place of 4000 right over here we have to place 6000, so our first node will point to our third node. So let's write a logic. This 4000 is the place for q to q is 4000, so q to left, sorry, q to right is 6000, q to right is 6000, and then q to right to left is 4000. So in place of q to right, q to right is 6000, so 6000 to left is 4000. So in place of this we have to give the value 2000. We have to give the value 2000 so that it points to our first node. So 2000 is the value for p. P has the value 2000. And also in place of this 4000, we have to place the value 6000, which is the value for our third node, location of third node. So in place of p to right, in place of p to right, we have to give the value 6000. So 6000 is the value for q to right. Q is 4000, so 4000 to right is 6000, sorry, q to right. Now after creating a connection between our second node and our third node, we can simply get rid of this second node. We can simply get rid of our second node, but first we have to insert, in place of 6000 we have to write null, and in place of 2000 also we have to insert null. Then finally we can free this node. As we know, this node is being pointed by our pointer q. So in place of q to, this one is right, so in place of q to right we can directly insert the value null, and in place of q to left as well, in place of 2000, so q to left we can insert the value null, and we can simply free q so that there is this node get deleted. Actually it doesn't get deleted, but it's no longer in our linked list. So this is all we have to do to delete the node if it's in location other than 1. So let's write this clearly in our algorithm. In else part, first of all, in place of p we have to give the value of root so that the p and root both points to the first node. And in order to pass the control we have to write the logic, the while logic. I is less than location minus 1. Here I value is equal to 1. So in order to traverse, what we should do is in place of p, we have to give the value p to right and then increase the value for I. After that, in place of q, we can give the value for p to right, so that now q points to the node which we want to delete. In our case, it was the second node. Now in place of q to right to left, so q to right is this node and the left field is this node. So in this place we are giving the address of this node, which is held by our pointer p. So we have to give the value p. Whatever is in the p we have to write here. So in this case it was 2000. So now in place of p to right here we should insert the value 6000. So for that, for p to right, we have the value 6000. So 6000 is simply q to right. You can observe here. So q to right, we are inserting in p to right. So to get rid of this node, finally what we can do is we can write here null and null. So in place of q to right and also in q to left, we can simply place the value null. So here we have null and also right here we have null. Now finally we can free this q. And this completes our algorithm. So our new connection right here after deleting is this first node point to third node point to first node, and this is all you have to know while deleting a node in double linked list. I hope it's clear, and thanks for watching.